Right now, a storm is brewing somewhere on Earth. Lightning tears across the sky, and if you were standing close enough, you would see the flash long before you heard the thunder. You have always known this, but have you ever wondered why? You probably learned as a child to count the seconds between the flash and the rumble. It seemed simple, just a trick, but hidden inside that tiny delay is one of the deepest discoveries humanity has ever made, because that gap is not an accident. It is a doorway into an idea so strange that when scientists finally understood it, it changed forever how we think about space, time, and reality itself. The race between light and sound was never just about speed. It was about the universe, and the answer is still difficult to fully grasp. Let us begin somewhere unexpected. With you. From the moment you were born, your eyes and ears have quietly disagreed about when events actually happen. Your eyes detect light. Your ears detect sound. Light races through space at nearly 300 million meters every second, while sound crawls through air at only about 343 meters per second. The difference is enormous, almost 1 million times. Every clap, every barking dog, every closing door reaches your eyes before it reaches your ears. Your brain hides the difference. It calls them simultaneous, but they never truly were. So when did humans first notice this? The answer is surprisingly ancient, much older than science. Greek philosophers watched distant ships rowing across the sea and noticed the splash arrived after the movement itself. Aristotle wrote about it, but he stopped there. He believed sound simply traveled differently through different materials, leaving the deeper mystery untouched. For almost 2,000 years, nothing changed. Then, the 17th century arrived. Everything changed. A man named Galileo asked a dangerous question. Could humanity actually measure the speed of light? He placed lanterns on distant hilltops. He waited. One person uncovered a lantern. The other responded immediately, and Galileo measured the delay. The experiment failed. Completely. Light was simply too fast for human reactions to detect. But failure taught something important. Light was unbelievably fast. Perhaps faster than anyone had ever imagined. Sound behaved differently. It cooperated. Scientists timed cannon fire, measuring the gap between the flash and the explosion over long distances. The numbers worked. The speed of sound could finally be measured. Exactly the same way you estimate the distance to lightning today. Light refused to surrender until one astronomer looked far beyond Earth. In 1676, Ole Roemer was studying Jupiter's moon Io, hoping only to predict its orbit. Instead, he discovered something extraordinary. The eclipses arrived early when Earth moved toward Jupiter, and late when Earth moved away. The pattern never changed. It made no sense, unless light itself needed time to cross the extra distance through space. For the first time in history, light had a measurable speed. Scientists refined the number again and again. By the 19th century, Hippolyte Fizeau measured light using a spinning-toothed wheel and a distant mirror. The answer was astonishingly close, but another mystery remained. What exactly was light traveling through? Sound needs air, or water, or steel. Without matter, sound simply cannot exist.
So surely light needed something too. Scientists imagined an invisible substance filling all of space. They called it the luminiferous ether. It seemed obvious. It seemed necessary. It did not exist. Then came one of history's greatest experiments.
Michelson and Morley. Using an incredibly precise interferometer, they searched for Earth's motion through the invisible ether. The result? Nothing. No difference. Light travelled exactly the same speed in every direction. The ether vanished overnight. Now everything became strange. Very strange. Imagine standing beside a train moving 50 kilometers per hour while someone throws a ball toward you from inside. The speeds add together. That feels obvious. But light refuses to obey that rule. Fire a laser from a spaceship moving at half the speed of light. The beam still travels at exactly the speed of light. Always. For everyone. How can that possibly be? One young patent clerk asked exactly that. Albert Einstein. Instead of rejecting the impossible result, he accepted it completely and allowed the consequences to reshape reality itself. Space could change. Time could stretch. Distance could shrink. Two people could disagree about whether events happened at the same moment. This became special relativity, and every experiment since has confirmed it. Everything followed. GPS satellites, particle accelerators, black holes, the Big Bang, the expanding universe. All because light keeps the same speed for everyone, while sound changes depending on its surroundings. Sound is flexible, light is not. Cold air slows sound, steel speeds it up, and in empty space, sound disappears completely. Light behaves differently. It remains the nurse's constant. No negotiation. No compromise. Now, return to the storm. Watch the lightning. Count the seconds until the thunder finally reaches you. You are doing exactly what your ancestors once did. But now you understand why. You are witnessing the difference between something tied to matter and something that is not. One signal depends on the world around it. The other does not. That simple gap between flash and thunder quietly reveals the architecture of the universe itself. Richard Feynman once suggested that nature only begins to make sense when we stop expecting common sense. Light proved that long before we accepted it. Roemer saw it. Michelson and Morley confirmed it. Einstein explained it. You live at the slow end of reality. Everything you hear travels at the speed of sound. Everything you see arrives carried by light, connecting you not only to your surroundings, but also to stars, whose journeys began long before humanity existed. The next time you flip a light switch, listen carefully. The room fills with light almost instantly, while the click reaches your ears just a little later. The universe does this every single time, without exception, because one speed can bend, and one never will. The next time a storm rolls across the sky, count the seconds. You are not only measuring the distance to lightning, you are witnessing the difference between the universe's two languages, the one that bends and the one that never does. That is the speed of the universe talking to itself. End.
Welcome to TerraMind, explorers!